Good morning, dear students. In the previous video, we have covered from question number 1 to question number 5. In this video, we will learn from question number 6 to question number 10. So, let's start. So, here you can see the question number 1, that the first question is, which of three is traveling the fastest? So, here, so A, B and C, out of this, which one is traveling fastest? So, in a graph, distance time graph, if you represent the motion of a body in distance time graph, larger is the slope, larger is the speed. The slope means this angle, the angle between the horizontal axis and the line. So here, if you draw a horizontal line from here, this is the angle. If you draw a horizontal line from here, this is the angle. So you can see out of these three angles, this one is the greatest one. Hence, the answer is B. The speed of B is more. Are all three ever at the same point on the road? That means, is there any chance that A, B, C will be parallelly move at certain point? Will they meet at certain point? The answer is no. Why? Because you can see that this is B, this is A. Between A and B there is a common point. Means at this point, either B will overcome A or A will overcome B. And this is the second point where A and C will meet, but there is no such common point between these three lines. So the answer of this question is no. Now question number C and question number D, these two are based on totally your standard 5, standard 6 graph paper. Okay, so right now we are in standard 9. You have already covered graph paper for 2-3 years. So I hope you should be able to solve these questions. So see how far C has traveled when B passes A. When B passes A, what is the distance traveled by the C? How far B has traveled by the time it passes C. So these two are same question. Try to solve this question on your own. I hope you will be able to solve this question. It's very easy, but still if you have any doubt, I will clarify your doubts. Okay, so now let us move to the next question. Okay, this one, question number 7. A ball is gently dropped from a height of 20 meters. So this is a ball, suppose this is the ground. This distance is 20 meters. So here this is 20 meters. So what is given here? What is this 20 here? S. That means displacement is 20 meters. If its velocity increases uniformly, see its velocity is uniformly increasing. So here as the ball is dropped, its initial velocity is 0. That means here u at this point u is equal to 0. At this point v, what is final velocity? We don't know. Acceleration is given 10 meters per second. With what velocity will it strike the ground? After what time will it strike the ground? So here you need to calculate two things. First is what is the velocity of the body, this one. What is the time taken by the body to cover this distance. Okay. So here we know that S is equal to ut plus half it square. What is S? 20 meter. So 20 is equal to ut, but initial velocity here is 0. So 0 into t is 0. So s equal to ut, that part becomes 0 plus half at square. So half, what is A? A is given 10. So half into 10 into t square. T is not given. So here you can solve this question and you can find the value of t. So see, if 2 will come here, it will become 20 into 2, that is 40, divided by 10, that is 4. So t becomes 2 seconds. Okay, solve this one. Now when you find out the value of t, you can easily find out the value of v. So v is equal to u plus at. What is u? U is 0, then at. A is 10, t is 2, 20 meter per second. So v should be 20 meter per second. Okay. Now I hope you understood question number 7. Then question number 8. Find out How far does the car travel in the first 4 seconds? So here is the graph paper. So with the help of this graph paper, you need to solve question number 8. So here, find out how far does the car travel in the first 4 seconds. So this is the first 4 seconds. So here, draw an imaginary line like this. So see, this is speed, this is time. Speed time graph. The curve shows that uh, the distance traveled by the body, but you can see that this curve is little bit bent. It is not straight curve, it is exponential curve, or it is band curve. So right now, with the knowledge that we are having for standard 9, we will not be able to solve this question. If you consider this one as a curved line, we will solve this type of question and go to standard 12 when we'll study about integration. So for now, we consider this one as a straight line. In your exam also, if this type of question is asked, you consider this one as a straight line. Otherwise, the knowledge right now we are having, we will not be able to solve it. We'll skip this part. So this becomes a right angle triangle, this one. So half into base into height, half into base, that is 4, height is 6. So 6 into 2, that is 12. So 12 meter. So at 4 second, for the first 4 second, the distance traveled by the body is 12 meter. Set the area on the graph represent the distance traveled by the car during the period. You need to set the triangle. This part of the graph represents uniform motion of the car. See, in case of uniform motion, speed has to be constant from, as you can see, from 6 second to 10 second. This is a straight line. So this is the answer. From 6 second to 10 second, this is uniform motion of the car. Okay. Now let us go to another question. There is question number 9. See, this question number 9 is very important. It is generally asked in the exam, this type of question. State which of the following situations are possible and give an example for each of these. So first question, an object with constant acceleration or zero velocity. So is it, in this question it is asking you that is it possible that the object is moving with zero velocity with constant acceleration. So first thing that will strike in your mind that if the velocity is zero, how acceleration is possible? Okay, so let me clarify it out. Suppose this is a stone. If you throw a stone in this vertically upward direction, then what will happen? This stone is being pulled by the gravity of the earth, and the gravity of the earth, everybody knows that it is constant, and its value is approximately 9.8 meter per second square. So here the acceleration is constant, but the speed or the velocity of the body is decreasing. At this point, the velocity is maximum. When the body starts moving in the upward direction, the velocity gradually decreases, and at certain point it becomes zero. When the velocity becomes zero, the body starts falling on its own due to the gravitational pull of the earth. So at this point, the velocity is zero, but the gravitation is not zero. The acceleration due to gravity is not zero. It is constant. It is 9.8 meter per second square. So yes. Now second, an object moving with an acceleration but with uniform speed. So here, is it possible that any object moving with uniform speed will have some acceleration? No, it is not possible, because you know that acceleration is v minus u by 2 from first equation of motion. So when v equal to u, numerator becomes 0, so it becomes 0. So this is no. An object, see this one, an object moving in a certain direction with an acceleration in the perpendicular direction. Yes, it is possible. When the object is moving in a circular path, it is possible. Well, suppose at this point we will consider this is the direction of velocity, okay, and this is the direction of acceleration. Okay, both are perpendicular to each other. So for now, just see that whenever the body is moving along a circular path, this is the case. Now see, 10th question, last one. An artificial satellite is moving in a circular orbit of radius 42,250 km. This is the radius. Artificial satellite moving in a circular orbit. Circular orbit. It is moving along a circle like this. As radius of the circle is given, you can find out its perimeter by multiplying 2 pi. 2 pi into this one will give you the perimeter of the circle. Now calculate the speed if it takes 25 hours to revolve around the earth. So suppose the satellite is moving from this point, this is earth, from this point to a complete revolution, it will take 24 hours. So This is the perimeter. You will find 2 pi r. 2 pi into 42,250, you will get 2 pi r, that is perimeter, or the distance traveled by the satellite, divided by time. Time is 24 hours. So displacement divide distance divided by time, you will get speed of the satellite. Okay, so these are the explanations from question number 6 to 10. I hope you must have understood this one. After watching all my videos that I have uploaded, you should be able to solve all these questions. But still, if you have any doubt, you can ask me anytime. You can comment. Okay, thank you and have a nice day.